Imagine your app powering a real-time social feed, a bustling e-commerce grid, or a vibrant dashboard, and suddenly your users experience lag, sluggish scrolling, or even browser slowdowns as data updates and lists grow. This is a critical pain point in modern React development, efficiently rendering large or frequently updated dynamic lists. Even with React's virtual DOM and clever diffing, unnecessary re-renders can sneak in, silently draining performance and user satisfaction. In this tutorial, you'll gain a hands-on understanding of how to harness React's built-in optimization tools, PureComponent for class components and React.memo for functional components, to deliver lightning-fast, scalable list rendering, all without the crutch of third-party libraries. You'll learn exactly how React's rendering model works, how shallow comparison affects your components, and how to structure your code so that only the items that actually change re-render. We'll break down both paradigms side by side, demonstrate real-world patterns, and uncover subtle pitfalls that can sabotage performance even in experienced teams. Why is this so important? Because in production apps, especially those with real-time updates or vast datasets, every wasted render impacts responsiveness, battery life, and your users' trust. By mastering these techniques, you'll not only build UIs that feel instant, even under heavy load, but also write code that's easier to maintain and scale as your app grows. If you're serious about delivering robust, high-performance React applications and want to stay ahead of the curve with actionable deep dive tutorials, make sure to subscribe. You'll get ongoing access to the latest strategies, real-world examples, and expert guidance to keep your skills sharp and your apps blazing fast. To understand how React optimizes list rendering, picture a well-organized library. Each book has a unique code, and librarians only rearrange or update books that truly change, rather than reshelving the entire collection each time a new book arrives. In React, this selective updating is managed by two primary strategies: PureComponent for class-based components and React.memo for functional components. Both act like vigilant librarians, checking if a book's content or place on the shelf has truly changed before investing the effort to update it. With dynamic lists, think of endless social feeds or product catalogs, the stakes are higher. If every item re-renders for every change, the UI lags. PureComponent and React.memo step in as gatekeepers, performing shallow checks on each item's props. If nothing meaningful has changed, they halt a re-render, conserving resources. Imagine a dashboard where only one conversation updates at a time. Thanks to these optimizations, the rest of the list remains untouched, making the interface feel instantly responsive, even with hundreds or thousands of items. This core principle, render only what's necessary, lies at the heart of lightning-fast dynamic lists in React. Comparing PureComponent and functional components with React.memo is like evaluating two expert editors using different checklists to approve article changes. PureComponent is built into class components, automatically applying a shallow comparison between previous and next props and state. If nothing has changed by reference or primitive value, it skips the update, behaving as a strict but efficient editor for each article, component, in a magazine, list. Functional components, on the other hand, rely on React.memo, a higher-order function that wraps the component and performs a similar shallow prop comparison. Both editors are fast, but their workflows differ. PureComponent is always on for class components, while React.memo must be explicitly applied. In real-world apps, functional components with React.memo have become the preferred pattern, offering flexibility with hooks and easier readability. However, the underlying optimization, comparing incoming data references, is the same. The crucial difference emerges in usage. PureComponent can also check state, while React.memo focuses strictly on props. In dynamic lists, this means that for optimal performance, you should ensure that the props passed to these components are stable, unchanged unless the underlying data truly changes. Otherwise, both editors will be forced to reapprove every article, even when the content is the same, negating their efficiency. This careful management of data references and component boundaries defines the difference between a sluggish and a lightning-fast React app. This is the main application file enabling you to switch between the class-based PureComponent and functional React.memo list implementations. It demonstrates the core UI, mode toggling, and integration of both list rendering approaches for direct performance comparison. This file implements the functional component approach for dynamic list rendering. It uses React.memo for individual conversation items, ensuring only updated items re-render. The interval simulates real-time message updates by modifying a random conversation every 2 seconds. This file defines the functional conversation item component, wrapped with React.memo to prevent unnecessary re-renders unless its props actually change. This is a critical optimization for large dynamic lists. This file contains the class-based list implementation utilizing React.PureComponent for each conversation item. It updates a random item every 2 seconds in the state, ensuring via PureComponent that only the changed item re-renders. This file implements the conversation item as a React PureComponent, enabling shallow prop and state comparison to minimize unnecessary renders during dynamic list updates. This mock data file provides an array of 1,000 conversation objects, each with a unique ID, title, and last message. It is used as the source for dynamic list rendering in both approaches. This is the entry point for the React application, initializing and rendering the main app component into the DOM. This test suite verifies that both list implementations properly render conversation items. It uses React testing library to assert expected UI output for both class and functional variants. This configuration file defines the project dependencies, including only React and testing tools, and provides essential scripts for running and testing the application. The application loads, presenting a prominent header titled React List Rendering Optimization Demo at the top of the page. Just below the header, navigation buttons appear, allowing toggling between functional React.memo and class PureComponent modes. The interface focuses initially on the functional component mode, with the corresponding navigation button active. The camera view shifts to hover over the header, briefly highlighting the demo's title and available navigation. Next, the focus moves to the main content area, where a large, scrollable conversation list is visible within a container labeled as the conversation list. After a short pause, the demonstration lingers on the functional React.memo mode, emphasizing the rendering of multiple conversation items. Each item in the list displays a conversation title, the latest message, and, for some items, a small unread badge indicating new messages. The interface slowly scrolls vertically through the conversation list, revealing many more items beyond the initial viewport. As the list moves, the continuity of rendering is smooth, and each item appears with consistent styling, ensuring that performance remains high even as many list items come into view. Following the scroll, the view pauses to allow observation of a dynamic update. One of the conversation items updates automatically, with its last message text and unread badge reflecting a recent change, simulating a real-time incoming message. The update is visually isolated, affecting only that specific item, while the rest of the list remains unchanged. A visible unread badge on a conversation item is then selected. The view scrolls to bring that item into focus, and a click interaction occurs. The unread badge disappears instantly, and the conversation item is visually highlighted to indicate it has been selected and marked as read. Below the list, a performance meter is revealed, displaying real-time feedback on rendering efficiency, such as the number of renders or update rates. The meter remains calm and consistent, indicating optimized performance. An informational panel is then brought into view, summarizing key optimization details, such as the use of React.memo, how memoization prevents unnecessary renders, and best practices for prop management. The panel provides visual and textual cues that reinforce the benefits of the chosen optimization strategy. Next, the navigation switches to class PureComponent mode. The interface updates to reflect the class-based implementation. The conversation list is rebuilt using PureComponent, but the visual structure and list content remain nearly identical. The scroll action is repeated, gradually moving through the list and revealing further conversation items. The rendering remains responsive and performant, with no lag even as hundreds of items are shown. Once again, a timer-driven update occurs. One conversation item updates to reflect a new message, and its unread badge or message text changes. The update is localized, with only the affected item re-rendering, demonstrating PureComponent's effectiveness. A new unread conversation item is then selected in class mode. The view scrolls to bring it into focus, and a click interaction marks the conversation as read, removing the unread badge and visually highlighting the selection. The performance meter and information panel are shown again, this time describing the PureComponent approach and confirming that rendering remains efficient. Finally, the navigation switches back to the functional mode, illustrating how toggling between implementations is quick and the user experience remains consistent. The demonstration concludes, having showcased both optimization strategies and their impact on real-world dynamic list rendering, emphasizing smooth updates, localized re-renders, and high responsiveness throughout. You've just unlocked the core techniques to make your React lists lightning fast without adding any heavy dependencies. By mastering PureComponent and React.memo, you're positioned to build interfaces that stay smooth, even as data grows and updates in real time. Imagine scrolling through massive dashboards, chat feeds, or product catalogs, and knowing your app will stay responsive because you've structured your components for maximum efficiency. Apply these patterns to your own codebase and watch performance issues fade away. For even more practical strategies, hands-on demos, and the latest React optimization tactics, hit subscribe now. This channel is dedicated to accelerating your React expertise with real-world examples you can put to use immediately, so you can ship better apps, faster, and with total confidence.